October's going to lecture. Okay, sure. Come on. Oh, there we go. Oh, no, you have to lecture. You can't run away. You can't. Oh, no, you. All right, she just ran out of the classroom. We have a substitute lecturer today. I'll try to make sense of her lecture notes. We'll see how it goes. She's on strike. All right, she's on something right now. Anyway, we're 2 minutes late. Let's get going. Today we're going to be talking about 9.4, the sum to product and the product to sum formulas, which are these last two. And I know you're going to be very sad. Last two meaning no more identities after this. Okay, so after this, we're going to start talking about trig equations, which we're going to have to use these identities, these existing ones. All right, so again, a lot of today is really just twofold. Can you use identities and plug in formulas? And the other half is just preparing you for calculus, okay? So much of what we're doing in this entire chapter, really kind of the whole class, is preparing for calculus. But by the way, you know, sometimes college algebra and trigonometry are combined into one class called pre-calculus. So the whole point of these classes is to prepare you for calculus. So that's kind of what's going on. So we're going to talk about 8 formulas today. The most, well, ever since 9.1. 9.1 had more than 8 formulas, but 8 formulas. But essentially, they're very similar, right? You just have to figure out which one to use. But it's not even that hard to find out which one you use. Just, you know, do you have, just depends on what you have, okay? So I don't think that'll be a trouble for most people. Usually the trouble for a lot of people is going to be figuring out which one to use. All right, so essentially all of these just come out of the angle sum formula for sine and cosine. These formulas right here give us all 8. And I'm not going to derive all 8 of them. I'm not even going to derive one of them. But you can really see that if you just choose 2 angles right here, you just rearrange some terms, and then you add these 2 equations together, or maybe subtract these equations from each other, and you can get a lot of interesting stuff from that. And what that does is let you, if you have cosine and sines, any combination of those multiplied by each other, you can turn them into addition, which is very helpful for integration in calculus. And going the other way is more of like an exercise. I don't see these ones use that frequently in mathematics. The product of sum are used more in my experience, but we're going to be doing both of them. All right, so here we go. Example 1. Write as a sum. So part A, 2 cosine of 7x over 2 times the cosine of 3x over 2. So if we were trying to integrate this, if we were doing some calculus problem, we would not be able to integrate this. Okay, we would have to rewrite it, and that's exactly what we're doing. Integrating, well, you could integrate it. I'm pretty sure integration by parts would work, but it'd be a nightmare, and you don't want to do this. If we just use the product to sum formula right here, it's going to be in a lot nicer form. But all you really need to know for this class is how to use the formula. So first off, we have to figure out which formula we're using. We have a cosine times another cosine. So we need to write it as a sum, and we have a product. We have a product. We need to write it as a sum. That we're going to need product to sum here. And it's cosine on both of them. So we don't use the first one. That's sine on both. We use the second one, cosine of u, cosine of v. So let's copy this down, okay? We know, off to the side, the cosine of u times the cosine of v is equal to 1/2 times the cosine of u minus v plus the cosine of u plus v. All right, and it's really helpful to write this down on the side because this has some complications, right? This right here is our u. This right here is our v. Technically, it doesn't matter which one's which. And so we're going to use this, but instead of writing u's and v's, we're going to write u is 7x over 2. V is 3x over 2. All right, and that's all there is to it. Identify what formula to use, identify u and v, and then just evaluate. Okay? And again, more importantly, we also have a 2 in front of this. So that's going to end up canceling. So we have 2 times the product. And what is the product? The product is 1/2 times the cosine of u. What is u? 7x over 2. Minus v. What is v? 3x over 2. Oh, you can already see how nice this is going to be. Anyway, plus the cosine of u plus v. 7x over 2 plus 3x over 2. This is probably one of the nicest problems you're going to get in the whole section, because look what happens. We have 2 times a half. Those cancel each other out. We just have a 1 in front. We don't need the brackets anymore. We're just left with cosine of 7x over 2 minus 3x over 2. That's just 7x minus 3x, all divided by 2. 7x minus 3x is 4x. So we're left with 4x over 2. We'll reduce that even more later. Plus the cosine of their sum. 7x plus 3x is 10x. And now, just super quick, 4x over 2 is just 2x, plus cosine of 5x. And that right there, what we just did, is most of the whole section. If you can do this, you can do almost the entire section. Okay, so yeah, let's do a couple more. Let's do part B. Sine of 4 theta times cosine of 2 theta. All right, so first step, identify what we need to use here. We have a sine and a cosine. Sine, sine, nope. Cosine, cosine, nope. Sine, cosine, sure. Technically, you could also use this one down here, cosine, sine. But let's use sine, cosine, it's in the right order. So we're going to use the sine, cosine one, that's the third one. And that tells us that sine of u, cosine of v, again, I'm working off to the side is usually a good idea, is going to be 1/2 the sine of the sum plus the sine of the difference. Sine of u plus v plus sine of u minus v. All right, and that's all we have to do. This is our u, this is our v, and we just plug it in. So it's going to be the 1/2 sine of their sum. U plus v is 4 theta plus 2 theta. Plus the sine of their difference. U minus v is 4 theta minus 2 theta. That's really it. Okay. We'll keep the 1/2 on the outside, but I don't have a problem with it if you put it with the 1/2 on the inside. 4 theta plus 2 theta is just 6 theta. All right. 4 theta minus 2 theta is just 2 theta. Okay? And that's it. And again, notice what the question is asking. The question is asking you to write as a sum. It's not saying you have to simplify it. This is not simpler than that. I don't know if either of these is simpler than the other. The important thing is rewriting it and being able to rewrite it into a tool that may or may not be more helpful given the problem. And again, this will also pop up. And oh, I just thought of an example where we want to go the other way. So like I said, it's a lot easier to integrate when you have sums. But if you're solving an equation, having a product is much, much nicer. So that's 2 examples of when we might want it as a sum and when we might want it as a product, okay? And we'll be solving equations next week, actually, okay? When we do 9.5, which will be the sad end to chapter 9. Most people will be very happy to be into chapter 10, but chapter 9 is my favorite, okay? This is, again, most of what we're doing today. Let's just do another one. Just get more practice. Okay, part C. Cosine of 3 theta, sine of 5 theta. So again, figure out which one you have to use. We've got a cosine and we've got a sine. Sine, sine, cosine, cosine, sine, cosine, cosine, sine. Okay, so we use the last one. And we just write it down. The cosine of u times the sine of v equals 1/2 the sine of u plus v minus the sine of u minus v. What's our u? 3 theta. What's our v? 5 theta. We just plug it in. 1/2 sine of their sum, which is 8 theta, minus the sine of their differences. 3 theta minus 5 theta is negative 2 theta. This one's actually a little bit more interesting than the other ones. Because in the other ones, this is where we stopped. We can do one more step here. A little throwback to 9.1 actually. Anybody see it? We can do something with this negative right here. Sine is an odd function, which means the negative comes out in front. Right here, where you find that is in the parity identities. Sine of negative angle is negative the sine of that angle. Okay, so there's one extra step we can do here. 1/2 times the sine of 8 theta plus, because the negative comes out in front, the sine of 2 theta. And that's a little simpler. Okay. We have now finished 1/3 of the section, which is pretty crazy. And we're almost done for today. Let's do one more in this section, and then we'll go on to example 2. So let's do cosine of 11 pi over 12 times the cosine of pi over 12. We don't have to use the product to sum here. If we want an exact answer, if we want an approximation, we could just plug this into our calculator. But if we want an exact answer, we could do what we did in the previous sections and write this as a sum or difference of angles that we do know. And I think that'll work. It might not work here, actually. I think that would work. But what will work much easier is if we rewrite this from a product to a sum. Because notice, whenever you do product to sum formulas, you always get the subtraction of the angles and the addition of the angles, the sum of the angles on the inside, which is really nice to have here. Because if we add the angles, we get 12 pi over 12. That's just pi, which is easy. If we subtract the angles, we get 10 pi over 12, which is 5 pi over 6, which is also maybe not easy, but much easier. And it's going back to the start of the class in chapter 7. So it would behoove you to use a formula here. So we have cosine, cosine. Find the cosine, cosine. Not this one. Yeah, this one's cosine, cosine. Just 1/2 cosine of their difference plus cosine of their sum. So go off to the side. You say cosine of u times the cosine of v is equal to 1/2 the cosine of their difference, u minus v, plus the cosine of their sum, u plus v. Really, this whole chapter is just, can you use formulas? Can you plug in formulas? What's our u? This. What's our v? That. So we get 1/2 times the cosine of their difference. It's going to be 11 pi over 12 minus pi over 12. I'll write it out. 11 pi over 12 minus pi over 12. Plus the cosine of their sum, which is 11 pi over 12 plus pi over 12. And things are going to get really nice as we continue here. 11 minus 1 is 10. So we have 10 pi over 12, which again is 5 pi over 6. And when we add them, we get 12 pi over 12, which is just pi. Okay? Remember, for cosine of pi, pi is 180 degrees. That's a quadrantal angle right here. So what we do is we look at the unit circle, and cosine, remember, is the x-coordinate. So on the unit circle, right, remember that's a circle of radius 1. So, right, this is 1, 0. This is 0, 1. This is what we want, -1, comma 0. The x-coordinate's -1, the y-coordinate's 0. So this right here is just 0. Nice. Now we just have to find the first one. 5 pi over 6 is almost pi, but we're missing a pi over 6 for it to be pi. So we almost go pi, but we're missing pi over 6. So we have this angle with a reference angle of pi over 6. It's in the second quadrant, so the x-coordinate is going to be negative, and you can copy down your triangles that I will give you. You haven't been able to see anything for like 15 seconds. Sorry. Forgot to scroll down. So the x-coordinate's negative right here. We're moving to the left, so that's negative. We're moving up, so this is positive. Cosine's adjacent over hypotenuse, which is negative root 3 over 2. So all that work. And really, we could distribute the 1/2, but the 0 is just going to be a 0. So we just multiply these two together, negative root 3 over 4. We have a really nice exact answer for this problem. Okay, so that's another one of the perks. This one's kind of contrived and I don't see it very much, but there's one way that you could utilize these formulas. All right, last example problem of the day. Almost done. Example 2. We'll do the other half tomorrow. And we're going to go a little slower the next 2 weeks while my face-to-face class catches up, and then we're just going to merge the lectures together. Okay? So example 2 is going to be verify. All right, verify cosecant squared. No, let's not do that one. That one's awful. Tangent of theta. I mean, all these are kind of weird problems actually. Tangent of theta times the cotangent of theta minus the cosine squared of theta equals sine squared of theta. This is from the book, which I think is absolutely ridiculous. We're gonna do part A and B because these are stupid. These are stupid problems. This is not 9.4 at all. Right? You might think, oh, we have a product of angles. Let's find our product of sum formula. But none of these products of sums have cotangents or tangents. But remember that cotangent is just 1 divided by tangent. So, right, what's your left-hand side? Remember, when you verify, you need to start with one side and try to make it the other side. Our left-hand side is just, well, tangent times 1 divided by tangent. They're just multiplying by a reciprocal. That's just 1 minus cosine squared of theta. Well, 1 minus cosine squared of theta, we've seen that before. That's a Pythagorean identity. It equals sine squared of theta, exactly like we wanted. So this is literally just a 9.1 problem. And I'm pretty sure part B is as well. Let's just do it for practice. Cosecant squared of theta, this one's a little trickier, minus 2 equals cosine of 2 theta over sine squared of theta. So we have a lot of options here. Okay, you could start with the left-hand side or the right-hand side. If you start with the left-hand side, you could use the fact that cosecant squared is 1 plus cotangent. And why would that be useful? That's a Pythagorean identity. 1 plus cotangent might be useful because cotangent is cosine over sine. So this is cosine over sine in some bizarre way. Maybe that'll be useful. I don't know. But I would probably start with the right-hand side. The right-hand side, use the double angle formula for cosine. So let's start with the right-hand side. So right-hand side is going to be that. So we say, okay, what is the double angle formula for cosine? And your heart might skip a beat, because there's 3 of them. Which one do we use? Cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus sine squared. So we have to look at where we're trying to go. And if you choose wrong, you just have a couple extra steps and you'll get to the right answer anyway. But do we want a cosine squared and a sine squared? Or do we only want one of these? Either a cosine squared or a sine squared or both. What do we want? Well, if it's only a sine squared, then we're going to have a cosecant squared. Oh, that's good. And then a number. Sorry, a cosecant squared is the number part. And a sine squared would make it 1. Well, a cosecant and a number is what we want. So I think we want to use the one with the sine squared in it. Because if we used both, if we have a cosine, if we use one of the cosine formulas up here, then we're going to be stuck with a cosine over sine. We don't have any cotangents over here. Unless, of course, we use the substitution that turned cosecant to cotangent, which is what I'm saying. You can use any of these. And I'll show you that you can use any of them. But we're going to want to use the one that's 1 minus 2 sine squared. All right. So if you guess right, or if you can figure out which one's the optimal, it immediately gets way easier because this part's going to be the cosecant squared, and this part's going to be the negative 2. We just split up the fraction. This is 1 divided by sine squared of theta minus 2 times sine squared of theta over sine squared of theta. Well, these ones cancel. We're just left with a minus 2. 1 divided by sine squared is literally cosecant squared. So let's say you didn't know. If you didn't know, you just guess. Okay? Let's say we chose cosine squared of u, or of theta, minus sine squared of theta. Well, this works too. We still split it up. Because again, we have two things. Look at where you're trying to go. We have two things. So we want to get rid of this fraction bar and write it as two different fractions. Cosine squared of theta divided by sine squared of theta minus sine squared of theta divided by sine squared of theta. So again, that's cotangent squared of theta minus 1. We have a cotangent squared. We want a cosecant squared. So again, we use the Pythagorean identity. 1 plus cotangent is cosecant, or we rearrange that around, right? Go off to the side. 1 plus cotangent squared of theta equals cosecant squared of theta. But we have a cotangent, so subtract 1 from both sides to get cotangent squared of theta is equal to cosecant squared of theta minus 1. And if you want to write this identity on your sheet, you can. So this becomes cosecant squared of theta minus 1, and there's still that minus 1 from before. Collect like terms, you get cosecant squared of theta minus 2. So even if you guess wrong, you still get there just in a couple more steps, right? This is 1, 2, 3 steps. This is 1, 2, 3, 4, 5 steps. 2 extra steps if you guess wrong. And that is the big theme for all these verification problems, okay? There are a lot of different ways to do them. You just need to start going. And if you choose suboptimally, you can either rewind and start over, or sometimes you can just do a couple extra steps and still get there anyway, okay? And yeah, that's probably more than half of the entire section, all right? We'll do the other half tomorrow, all right? Anyway, have a good day, and please email me if you have any questions.